Hello children. In the previous session, we learned about physical changes. Now, in this session, we will learn about the chemical changes from the lesson Physical and Chemical Changes from Class 7 Science. Learning outcomes. At the end of this session, you will be able to understand about chemical change, rusting of iron and prevention, corrosion, galvanization, reason for color change in cut vegetables and fruits and its prevention. Activity to observe chemical changes. Keywords: chemical change, a change in which one or more new substances are formed. Rusting, corrosion, galvanization, a process wherein a thin layer of zinc metal gets deposited on iron objects. Before starting, let us look at the concept map of this session. A change in which one or more new substances are formed is called a chemical change. A chemical change is also called a chemical reaction. Chemical changes are very important in our lives. For example, digestion of food in our body, ripening of fruits, fermentation of grapes, etc. happen due to a series of chemical changes. A medicine is the end product of a chain of chemical reactions. Useful new materials, such as plastics and detergents, are produced by chemical reactions. Every new material is discovered by studying chemical changes. A change with which you are quite familiar is the rusting of iron. You might have observed the iron nails, iron gates, iron benches or pieces of iron left in the open ground for a long time. While observing, you might have noticed a brown layer on the surface of the iron articles. This is called rust, and the process is called rusting. This is one change that affects iron articles and slowly destroys them. Why do iron articles get rust when they are exposed to air for a long time? When iron is exposed to air for a long time, the oxygen present in the air reacts with it in the presence of moist air and forms a new substance called iron oxide as rust on iron articles. This process is known as rusting. Iron plus oxygen from air plus water gives rise to rust, which is iron oxide. The speed of rusting depends on the amount of moisture and time available to it. The more the humidity in the air, faster is the rusting of iron. Some of the ways to prevent rusting are: to not allow the iron articles to come in direct contact with oxygen in the air, water, or both. Apply a coat of paint or grease on an iron article. Now let's see what is corrosion. When copper utensils are exposed to air, we find a greenish coat on them. This greenish coat is formed when copper reacts with oxygen and carbon dioxide present in the air. This coat also protects copper from getting further corroded. It is an example of corrosion. Another method to prevent rusting is galvanization. You might have observed handles of bicycles, metal rims of bicycles and motorcycles, water pipelines, white coated metal railings fixed to steps in cinema halls and shopping malls, etc. You notice that all the above mentioned articles are made up of iron, but they don't rust even if they are exposed to air. To prevent iron articles from coming in contact with oxygen, in air or water or both, a layer of another metal like chromium or zinc is coated on them. This process of coating a layer of metal on iron is called galvanization. Now let's do an activity to understand the reason for color change in the cut fruits and vegetables. Take an apple, brinjal, and a potato. Cut each one into small pieces and expose them to open air for some time. You will notice that their outer surface has turned brown. This is because the fruits and vegetables, when cut, react with oxygen in the air. Some of the methods to prevent the coloring of vegetables and fruits after cutting are: put them in salt water. Salt water prevents the outer surface of the potato and brinjal from coloring. Small quantities of acids like vinegar or lemon juice in water will also prevent the browning of vegetables. You can also rub the surface of the cut fruits with juices of citrus fruits like lemon to avoid browning. Now let's do an activity to observe the chemical change. Take a small piece of magnesium ribbon. Bring the tip near a candle flame. It burns with a brilliant white, leaving a powdery ash behind. When magnesium burns in the presence of oxygen, it forms magnesium oxide in the form of powder ash, which is a new substance. Magnesium plus oxygen gives rise to magnesium oxide. Collect the ash and mix it with a small quantity of water and dissolve it. Another new substance is formed. Magnesium oxide plus water gives rise to magnesium hydroxide. Test the mixture with blue and red litmus papers to decide whether it is an acid or a base. Magnesium hydroxide is a base because it turns red litmus blue, while the blue litmus remains unchanged. Let's do another activity to observe the chemical change. Take a beaker half filled with water and add a teaspoonful of copper sulfate to it. Now add a few drops of sulfuric acid to the copper sulfate solution. We get a blue colored solution. Take some sample solution of it in another beaker and keep it aside. Add an iron nail to the solution in the first beaker and keep it undisturbed for half an hour. Compare the color of the solution in which the iron nail is dropped to that of the sample solution kept aside. Now, remove the nail from the beaker. We notice that the blue colored solution changes into a green color and a brown color deposit is seen on the iron nail. The changes that we notice are due to a reaction between copper sulfate and iron. The change of color of the solution from blue to green is due to the formation of iron sulfate, a new substance. The brown deposit on the iron nail is copper, another new substance. Copper sulfate solution, blue, plus iron gives rise to iron sulfate solution, green, plus copper, brown deposit. Let's do another activity to observe the chemical change. Take about a teaspoonful of vinegar in a test tube. Add a pinch of baking soda to it. We would hear a hissing sound and see gas bubbles coming out. Pass this gas through freshly prepared lime water. We observe that lime water changes to milky white, showing that the gas sent into the test tube is carbon dioxide. Vinegar plus baking soda gives rise to carbon dioxide plus other substance. Carbon dioxide plus lime water gives rise to calcium carbonate plus water. In these reactions, new substances like carbon dioxide and calcium carbonate are formed. From all the above activities, we have noticed that one or more new substances are produced in a chemical change. In addition to new products, the following may accompany a chemical change: heat, light, or any other radiation may be given off or absorbed. Sound may be produced. A change in smell may take place or a new smell may be given off. A color change may take place. A gas may be formed. When a substance undergoes a change in its composition, it is called a chemical change. In a chemical change, new substance is formed. A chemical change is also called a chemical reaction. The more the humidity in the air, faster is the rusting of iron. The process of depositing zinc on any metal is called galvanization. Thank you for watching.